Hello, this is Mr. Anderson from Kellogg Community College, and we are looking at the first day of trigonometry. And since we are taking a unit circle approach, I'm going to take a day to talk about the unit circle. So, first thing we're going to do here is just go over some basics here. What is the unit circle? And the unit circle is a circle with radius of 1. And this is going to give us a lot of building blocks to use in our future math classes, and this is how we're going to actually we're going to go back to the unit circle when we do things in this class too. First thing we should basically look at is we're going to talk about degrees in a circle. It's pretty common knowledge that a circle is 360 degrees. Whoops, little pen fault there, 360 degrees. But what I'm going to do is there's an extra worksheet kind of attached or maybe to the side of yours right now, and you'll actually see that this worksheet, if I switch to it quickly here, and there we go. This unit circle right here is broken into 24 sections. So each section is of the 360 degree circle is split into these little segments here and these little arcs. There are 24 of these pizza slices that go around the circle. So that means that when we talk about this or look at that picture right there, in terms of degrees, that 360 degree picture is split into 24 slices, which means that each slice is going to be about 15 degrees. What that allows us to do, it allows us to kind of highlight the major arcs or the major spaces on here with our angles here that we're going to need to use for our unit circle. So this would be 0 degrees or all the way around 360. We're going to focus on this measurement here, which is 30 degrees away from this start of the circle. So 30 degrees, another 15 would be 45, and this up here would then be 60. These are three of the most important angles of the unit circle, as we're going to find out so far. Taking this another 2 wedges, this would be another 30 for 90. Another 2 wedges here would take it to 120. And we're going to continue on, 135, and then we'll have 150. Taking another 2 wedges takes it to 180, or halfway around the circle. Then we go another 30 degrees here, so this is 210. This is 225, another 15 degree wedge. And then we're going to have another wedge here, which is 240 degrees. 2 wedges takes us down to the bottom of the unit circle, 270 degrees. 30 degrees this way would be 300. 315 for a 15 degree wedge there, and then finally 330 degrees before we go back around to our 360. So, if you can fill this in, it's unfortunate that this is going to go away when I clear the screen here, but this is, how we should kind of work from one worksheet to the other. So let's go back to the other worksheet here. There we go. Now we're going to talk about radians. What is a radian? Now, a radian is let me put this here, I might have to write a little small. It is a unit of an angle, comma, equal to an angle at the center of a circle whose arc is equal in length to radius. A radian is a unit of an angle equal to an angle at the center of a circle whose arc is equal to the length of the radius. Now, this sentence, or this definition, may not really strike true with you, but it came from the idea of the central angle theorem in geometry. Central angle theorem, which states that from the center of the circle, if we have a circle here, and we create a 90-degree wedge, the angle that's inside of that central angle, this is 90 degrees, this represents 90 degrees of the 360-degree circle, or a quarter. Now, to kind of show you where radians came from, we have a very common formula about the circumference of a circle. If you go around a circle, no matter what circle it is, no matter what radius it is, the circumference of that circle is always 2 pi r. So you take your radius, double the radius, and then multiply by this 3.14, non-terminating decimal here. This will always give you the circumference. So the circumference of the unit circle is 2 pi. And that's very important because what we can do is, like we labeled the angles from 30 degrees all the way to 360 degrees, we can do the same thing for the unit circle using radians. Because we know that the 360-degree circle is 2 pi around. All right, because the circumference is equal to 2 pi. So going 360 degrees around is, in a different measurement system, the radian system, 2 pi. So what we're going to have to do is do a little work here to try to show you how the degrees are going to, from that picture, work out to be radians. Now, there's conversion formulas that are pretty easy, but what I like to do is I like to kind of take a look at the picture of the unit circle here. There we go. So we take the picture of the unit circle and notice that, oh my gosh, look, there are, let me set this up here because we're going to be coming back to this again. Again, one trip around the unit circle is going to take us all the way to 2 pi. So halfway around the unit circle is going to take us to pi. Now you'll notice that it took us 12 little wedges to get 2 pi. So to derive this here, I'm going to basically think about it this way. If 12 wedges out of 12 give me 1 pi, then 24 pizza wedges out of 12 gives me 2 pi. So every 12 pizza wedges, or every 15 degrees in this case, or every 12 units, 12 times 50 degrees, or 180, gives me pi. All right, so let's go and see how I'm going to derive this. So what I'm going to do is count pizza wedges. 1, 2. So this is going to be 2 pizza wedges. This is 3 pizza wedges, 4 pizza wedges, 6, 7, 8, 9, 10, 11, 12 pizza wedges, 13, 14 pizza wedges, 15, 16 pizza wedges, 17, 18 pizza wedges, 19, 20, 21, and 22 pizza wedges out of 24. So this is how you're going to see the radians get created for this unit circle. So let's go take this back to, let me go back to the notes. All right, so if you had that kind of from the previous screen still up there, what you would see is that when you get to 30 degrees, there are 2 pizza wedges out of 12, or 2 pi 12. So 2/12 of that pi is reducible to pi over 6. And pi over 6 is one of our elementary and fundamental parts of the unit circle, that 30 degrees is equivalent to pi over 6. Now, 45 was 3 pi over 12, so it was 3/12 of a pi, and that is simplifiable using just basic fraction skills to pi over 4. And then this would be 4 pizza slices over 12, so 4/12 of a pi is going to give me pi over 3. Just simplifying these fractions, these 3 are big, important radian measurements of 30, 45, and 60 degrees on the unit circle. And then we're going to get to 90 degrees, so took me 6/12, halfway there, so that's pi over 2. So 90 degrees is pi over 2. We're going to keep going here, 8 pi over 12, which is 2 pi over 3. 9 pi over 12, which is equal to 3 pi over 4. This is 10 pi over 12, which is equal to 5 pi over 6. And let's go with 12 pi. We're finally at 180 degrees, so we're 12 pi's out of 12 pi's out of 12, excuse me, and that reduces to just 1 pi, or just pi. So 180 degrees is pi units around the circle, or pi radians. So this gives us halfway through the circle. Now here's something that kind of like messes people up a little bit. This is 14 slices out of 12, not out of 24, because there are 12 slices per pie, so this is actually more than 12, so this is going to be a number that's bigger than 1 pie. This is 7/6. This isn't 15 over 24, it's 15 over 12, because it's 15 segments out of the 12 that makes a pie, so that's going to make 5 pi over 3. This is going to be 16 pi over 12, which again simplifies to a number that's actually bigger than 1. 4/3 is bigger than 1. And at the 3/4 way mark, 270 degrees around the corner, we got 18 pi over 12, which is simplifiable, dividing top and bottom by 6. 3 pi over 2. So here's all of our 90-degree marks here. We got pi over 2, pi, 3 pi over 2. You can see that we're going to get to the end here at 2 pi. 300 degrees, again, deriving this, 20 pi divided by 12 is going to give me 5 pi over 3. And then we have 21 pi over 12 gives me an answer of 7 pi over 4. And then 22 pi over 12 gives me an answer of 11 pi over 6. So these are all things that can be now put back onto the unit circle. So we can go back over here and we can flip to our other design. Whoops, sorry, flip to the same design. And now we can go around the unit circle and we can put up the things that we just learned. Now, maybe on your piece of paper you still have your angle measurements here, so 0, 30, 45, 60. So here we would put next to those, or below them, probably below would be a little bit easier, probably fit it in a little bit better. We could put in your measurements here. So we'll start off with the 30-degree mark. This is pi over 6. This is pi over 4. And this is pi over 3. Back at the top here, the 90-degree angle, we're going to look at pi over 2. And then over here, we're going to look at, this is going to be, just making sure I don't make a mistake here, 2 pi over 3. I've got then 3 pi over 4. And then over here at the 150-degree mark, I have 5 pi over 6. This is where it's really nice to have one worksheet, and the worksheet with the table you just made on one next to you to this one here, and this is gonna be pi because it's 12 out of the 12 wedges to get me to pi, because the full rotation around the circle is 2 pi. So I'm gonna just put that here just because I know I'm gonna get there. All right, so we're gonna go to 210 degrees, which is 7 pi over 6. We're going to go to 225 degrees, which is 5 pi over 4. And then finally we're going to go to 240 degrees, which is 4 pi over 3. All right, and then we're going to move to all the way down to the bottom here. This is going to be 3 pi over 2. And then here we're going to have, at 300 degrees, 5 pi over 3. Then we have 7 pi over 4. This is going to be at 315 degrees, and then at 330 degrees, 11 pi over 6. All right, so if you're building the unit circle, you can do so by counting up the wedges, and the more you do this, the more that these will click here. You'll kind of see that there might be some patterns, and we'll look at patterns coming up in just a bit here, but that's creating the unit circle from radians. Okay, back to Pythagorean theorem. We kind of need to talk about the Pythagorean theorem because we need it for the basis of the right triangles that are going to give us the points on our unit circle. The Pythagorean theorem is a squared plus b squared equals c squared, which means that if you take the hypotenuse of any right triangle, and this only works for right triangles, if you take the hypotenuse of a right triangle and square it, it would be equal to the sums of the legs squared. Now, this is true for all right triangles. Some notable examples is the 3, 4, 5 right triangle, and all of the scalar multiples like 6, 8, 10, and all those that are scalar multiples of these. Another popular one is the 5, 12, 13. So, and these are whole numbers, so there are, again, an infinite number of right triangles, but these are the ones that are whole number examples. And then a little bit more of an obscure one is 9, 40, and 41. And it's kind of fascinating to see lists of these right triangles that are actually whole numbers. So we need this right triangle focus, because what we're going to do is we're going to look at the second page here, and we're going to take our special triangles, our right triangle 45, 45, 90, and our two 30, 60, 90 variants, and we are going to put them into our unit circle so we can get our points, or the x's and the x and y distances of our unit circle. So I start off with, now the way that I formatted this, I started off with the 30 degree, the 45 degree, then the 60 degree triangle. I personally like to start with the 45 degree triangle because that seems to be the easiest one for most people to lock into. So again, this is a 45, 45, 90 triangle, and what we know about 45, 45, 90 triangles is that we have these two sides of the same length. So these sides are length x, which means that in our unit circle, if this 45, 45, 90 is inside it, the radius would be 1. So the question becomes, well, what's the distance of each of these values right here? Well, we can figure that out using the Pythagorean theorem by going leg squared plus leg squared is equal to hypotenuse squared. So this makes 2x squared, since this is common term. 1 squared is 1. Then we will divide both sides by 2, so x squared is equal to 1/2. Then we take the square root of both sides. We're going to exclude the negative value at this moment because we're going to take that into account when we go around the unit circle. So this becomes the square root of 1/2. Now we're going to break that down using a radical property, a little exponential property that says we can take the square root of the numerator and the denominator separately, which means that I have 1 over the square root of 2. We don't leave any radicals in the denominator, so we're going to multiply top and bottom by square root of 2. In doing so, we now have the square root of 2 in the numerator. Square root of 2 times square root of 2 is 4, which then simplifies down to 2. Because the square root of 4 is 2. Or the square root of any, like a square root times another square root is itself inside, and you're going to see that done a lot today. So this means that the height of this triangle, the y distance, is, whoops, I just wrote y because I said it, is square root of 2 over 2. And this means this x distance right here is square root of 2 over 2. So that is our triangle. Now the question becomes, like, why did you do that? Why did you actually create that? And now I'm going to take you to the unit circle and show you why. Because there are 45 degree triangles all over this unit circle. In fact, I'm going to take you to one of those 45 degree triangles right now. See, there it is. At the 45 degree angle, there is a 45 degree triangle right there. And its height we just found was square root of 2 over 2. So that's going to be the y value, square root of 2 over 2. And its distance from the origin along here is also square root of 2 over 2. Now we have 4 of these. We have one here. We also have one that's reflected over the y-axis, see right here. And that, I'm sorry, these lines aren't straight. That is going to be the point, and it's the same height. This is going to be square root of 2 over 2. And the distance from the origin, in this case, since it's in the second quadrant, negative square root of 2 over 2. All right. Now down here, without trying to draw a squiggly bad arrow, I have another square root of 2 over 2. But since this is in the third quadrant, do you kind of see what's going to happen here? These are going to be negatives. And over here in the fourth quadrant, we have another square root of 2 over 2, square root of 2 over 2. Except in this case, what's the negative? Is it going to be x or y? It's going to be the y. So here you see where now I'm taking into account all those positive and negatives for the square root based on which quadrant they lie. So there we have some, if not all, of our little points done for the 45, 45, 90 triangles. All right, now I'm going to go to the other special triangles, the 30, 60, 90. I'm going to start off with a 30 degree one. And the relationship in a 30, 60, 90 triangle, and this is from any kind of geometry class will spend some time working on 30, 60, 90 triangles, that the distance x here will be cut in half when you go from here to the hypotenuse to the shortest leg, and then from that shortest leg you multiply by the square root of 3 to get to the longer of the two legs. Knowing that, if we have the unit circle then, that first pizza wedge that's 2 wedges tall here, if the radius is 1, then we know this is 1/2. And therefore we would know that this would then be the square root of 3 over 2 for our distance from the origin. So this is for all 30-degree triangles right there. So let's go to our picture and let's plot these in. Alright, go to our unit circle here. Alright, so we're going to take our unit circle here and whoops, let me get the pen right. Okay, so what this means is now that I have my 30-degree triangle right there, I know my radius is 1, so this is going to be a height of 1/2. So I'm going to put my 1/2 there, because it's my height. And then across here, this is square root of 3 over 2. And so here we go, 3 to square root of 3 over 2. Now I have others of these. I have other ones that are like it. So let's reflect like we did with the 45-degree triangle. We're going to reflect over here and see that this is another 30-degree angle measurement. And this is going to be, you know, like that one, square root of 3 over 2 and 1/2. See, we're measuring it from the height from this line right there. So this is 1/2 tall. And the distance from the origin right there is going to be a negative since we're in the 3rd quadrant. Now you can see where else we're going to go here. We're going to go down here to this one, and this is going to be another 30-degree angle right there, and this is going to be a negative square root of 3 over 2 because we're in the 3rd quadrant, negative 1/2 because we're in the 3rd quadrant. And our final one in the 4th quadrant, I'm going to go to this one here. Again, sorry the lines aren't straight. This is going to be a positive square root of 3 over 2 because it's the x is positive distance from the origin, and then we have negative 1/2. Now, normally I would go back to the other worksheet or the other side, but what I'm going to do here is notice that I was going to talk about the 60-degree angle, and the 60-degree angle is actually right here, and it's going to be easy for you to see this if I just keep this screen here and change the color. You see from this angle right here, here is the 60-degree angle. And the 60-degree angle, again, is still going to have a radius of 1, but the 1/2 is going to be along the bottom here as the distance from the origin. So you'll notice that this is 1/2. And then this height right here is going to be the square root of 3 over 2. Because I don't need to go through a process other than just saying, hey, look, this is a 30, 60, 90 in a different orientation. So this is going to be 1/2 square root of 3 over 2. And then over here we're going to have another, let me draw a green triangle as well. Again, sorry the lines aren't straight. This is going to be a 1/2 and square root of 3 over 2, but because we're in the 2nd quadrant, this is going to be negative. Moving down below, here we go. We're going to go draw this here. This is going to be a negative, everything's negative in the 3rd quadrant, negative 1/2 and negative square root of 3 over 2. And here we go, we're going to drop this down here. And this is going to give me, this green triangle, this is going to give me a positive 1/2 because we're in the 4th quadrant where the x is positive, and negative square root of 3 over 2. All right, so there we go. Now, I'm going to bring back from the previous section here, I want to bring back those 45, 45, 90. Hold on a second here. Come on, give me. Sorry, my little pen is giving me little fits here. Okay, I'm going to bring this back from the previous part of the video. Square root of 2 over 2, square root of 2 over 2. All right, over here, negative square root of 2 over 2, square root of 2 over 2. Down here, everything's negative, negative square root of 2 over 2, negative square root of 2 over 2. And then over here we've got square root of 2 over 2, negative square root of 2 over 2. Okay, so what you're noticing is that there could be a good pattern for you to try to memorize this. if you're going to go in the counterclockwise direction, you'll see that it goes from in the numerators in the first one, 3, 2, 1, then 1, 2, 3, 3, 2, 1, 1, 2, 3. So if you go counterclockwise, your first x set of x values go 3, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. The numerators are always rooted, and no, you don't put a square root of 1. That's just silly. Just basically make sure that you have the pattern. And then if you want to go around this way for the back end here, it goes 1, 2, 3, 3, 2, 1, 1, 2, 3, 3, 2, 1. And again, there's many other ways in YouTube videos that show you little tricks to memorizing the unit circle. But the last thing we need on the unit circle here, and I'll change my pen color for one more time here. I'm going to change to, let's go with black. I'm going to look at the 4 easiest points to plot on this unit circle. Obviously, the 90 degrees, the 0 degrees, the 360, the 180, and the 270. This is the point 1 on x and 0 on y. It's the x-intercept. This point up here is 0, 1, the y-intercept. This is located at -1, 0, another x-intercept, and the negative y-intercept here would be 0, -1. So if you put all these down here with your radians and angle and degree measurements, you kind of have this filled out. All right, so that ends the first part of the unit circle. Thank you for watching.